All right, the next part of the analysis here. Tilt that some so you can see more of the board. So I went through and I cut off a piece of the string. Ideally, before I tied the string onto the string vibrator, I would have done the mass of that particular bit of string, mass and length of that particular bit of string, and found it. But I didn't, just because I was using a thicker string than I'm hoping that you'll be using a thicker string, and I knew I wanted to get it tied first because I might have to throw that out and do this video next week. But I did get it tied, but I did a different sampling of string. The other sampling of string that I did, it was 1.07 meters long. I found the mass was 8.2 grams, and I converted that to kilograms. So the linear density of this string that I was using, mass over length, is basically I did the mass, 0.0082 kilograms divided by 1.07 meters, and it came up with a linear density of 0.00766 kilograms per meter. And don't forget that 007 right there means you're licensed to kill, not be killed. So I want to find first the speed of this wave. The speed of the wave is the square root of my tension, 0.686 newtons, over my linear density, 0.00766 kilograms per meter, and then do the square root of that. And if you do that, you end up with a speed of 9.46 meters per second. Now you should check to make sure that meters per second is correct there, and I'm feeling pretty confident that it is. And ultimately what I want to figure out is what is the frequency of the vibration. Now, I know that the speed of the wave is equal to the frequency times the wavelength. That's a basic relationship. In another video, I talk about that. That's basically just distance over time. And so the frequency is the speed divided by the wavelength. And the speed here is 9.46 meters per second. And the wavelength is 0.505 meters. And so what I end up with is 18.7 hertz. Now, I know what the frequency is. I know 18.7 is not the right answer, but the basic one-shot analysis is this. You would want to do a whole mess of these things and come up with a slope, and it's written up in the lab, the more specific math that you need to do, but a graph is involved. But this, in essence, is the one-shot analysis of what we're talking about and for the frequency. So I hope you enjoy it. It actually is a pretty good lab. The results usually aren't that far off, but I'm not telling you what the right answer is, just that that's off. All right, until then.